I was thinking about what I was going to talk about at this conference as a keynote speaker, and I looked at the program and decided that there was an awful lot of nice, good, detailed stuff. Language things, library stuff and such, so I shouldn't do that. So I'm trying to talk about something more general, bigger ideas, and so I'm talking about the evolution, and I'm trying to look back and see why on earth does this happen? I mean, C++ has been declared dead at least 10 times every year for the last about 35, right? So let's look at it and why it didn't die in the crib or after that. And then I'm going to look a little bit about standardization and see what are the opportunities and the dangers now. And then I'm going to try and answer the question, where are we going? Where should we be going? How can we sustain what we have been doing so far and make it better? And then, this gets too philosophical, right? Then I have some concrete stuff about what we can do today, and that's how I'm going to end. But first we start with philosophy. There's a couple of philosophers, and there's a tension between ideals and principles and practicalities. And this has been going on for at least 2,500 years, and it hasn't stopped yet. But this is one of the tensions that we're going to talk about. And I am not going to give you long lists of features. Other people will be doing this. You don't have to, if that's what you want, you'll get it. And I can't give you really cool stuff. Go to the people that ship libraries and such and talk to some of the compiler vendors. Cool stuff is shipping. It's just not what I'm talking about. And then, again, going back, why did C++ succeed? What can we do? And I've heard many theories. My least favorite is being lucky. How do you stay lucky for 35 years? It takes hard work. And furthermore, one thing to point out. When I talk about C++, I'm taking a very C++-centric view. I could give a totally different talk about the industry and where C++ fitted and all of that kind of stuff. That's not what I'm doing. I'm very C++-centric. If you want to criticize me for it, fine. But remember, I know that too, and this is just lack of time. Okay, so let's look at philosophers. Here's Goethe. Dream no little dreams. In other words, what are we really trying to do? What's the big picture? What is the thing that sustains us, sustains C++ over decades, as opposed to days, weeks, months, years? Basically, my aim, and I hope many other aims are, simply to do things much better. And to do things much better in software development, you have to think differently. You have to construct your code differently. Just doing what we've always done, but slightly better, it's not going to get us there. It's going to get us the next project shipped, it's going to get us to the next year, but it's not going to sustain the language and the community for decades. So I would like type and resource safe, without any adjectives or other worries. I want the code I have to read to be simpler and clearer, easier to understand. This is important. I mean, that's what we spend most of our time doing. Usually looking at code that isn't finished or has bugs in it. And clarity, simplicity is really, really valid, and the language and the libraries can help there. That's what we want to do. And of course, this C++ has to be as faster than anything else. If you want slow code, you can get it. There's benefits sometimes to have slow code. You can have tools that allows you to write it sooner and such. And so, but anyway, as fast and simpler than anything else. And it has to be good at modern hardware. One of the strengths of C++, as I'll repeat a few times here, is it actually has mapped really nicely to hardware. Hardware is getting weirder. There are more pipelines, there's more forms of concurrency, there's more strangeness inside the compilers and optimizers. C++ is supposed to be good at that stuff. Let's keep it being good at that stuff. And then compile times, nobody really liked long compile times. Let's get much faster about this. And remember, in these things, I'm not talking percent. If you give me 10%, I'll be very unhappy. If you give me 10 times, I'll get happy. But that's not easy. Here we have an expert on difficulties, Niccolo Machiavelli, the famous historian of the Roman Republic, patriot and politician. There's nothing more difficult to carry out, nor more doubtful of success, nor more dangerous to handle than to initiate a new order of things. In other words, don't rock the boat, it's dangerous for you. Don't try and make things that are really new. Don't try and make things that are significantly different. And if you look at this, oh, I've lost, no, yeah. And of course, that is what I'm trying to do. It was also what Machiavelli was trying to do. He wrote a book trying to convince people to do it, and people convinced that he was wrong because he explained things the way they were, as opposed to the things that people pretended they were. I quoted that in the 3rd edition, and here's a continuation. The problem is it's dangerous because you make enemies of everybody who loves status quo. And people who would like something new tend to be lukewarm because it isn't there yet. They can't use it on their next project. They can't use it next year. And so there's an imbalance here. And so my conclusion is developers love minor changes that helps with current problems, and they don't really, the people that had a vested interest in status quo are stronger. Okay, then also remember, the best is the enemy of the good. We can't just sit around and wait for perfection. No, that doesn't get us to perfection. For starters, we don't learn anything. There's no feedback loops in trying to perfect. You have to move further. So we're going to talk a little bit about what concrete practical steps we can take now. That's the last quarter of the talk. And then, of course, we can't do it alone. And I'll point out that a lot of people have helped. There's just a few names there. If I had put everybody who needed thanks on this slide, I would have to use an 8-point font, and you couldn't have seen a single name. There's always these trade-offs. Okay, let's look at C++. Here's a graph. Some of the numbers are real, but it's hard to get numbers. In particular, the bottom and the top and some of the flex points are real. But I had to do some interpolation, especially around the 2002 plus minus a couple. The rest is pretty good. So let's see. I mean, we had a commercial release in '85. It's a long time ago. Why did we have exponential growth? I measured it as doubling every 7.5 months for 11 years. And then I couldn't count that high anymore. Numbers got too big. My sources were not good enough. And then obviously there was a slowdown. And it got a really serious slowdown just after 2000. And then it resumed. I mean, we have pretty good numbers for the last 3, 4, 5 years, and there's no doubt we are on an upward curve. So if I can explain this slide, I can actually get some guidance about what we should do to sustain it, what people would like, what will actually help people. So let's go back to the roots. Where does C++ come from? Some of you may have seen this slide. The past doesn't change very often. And so there are two sources of C++'s strength. The bottom line there starts with try and squeeze every cycle, every byte out of the hardware. It starts with assembler. David Wheeler there is one of the first people who can claim to have built a compiler. He certainly wrote the very first program on a stored program computer. And he was my thesis advisor, so he gave me a lot of information. BCPL, C, we know about that. And The problem is that most of the time we're not actually manipulating hardware. Some of us are, and C and C++ are good at it, should be good at it, it's designed to be. But there's another line of thought here, which is abstraction. Backus there and his team invented Fortran, which was the most significant improvement in programming so far. They lifted the language from the hardware up to something that was more suitable for humans. Very particular kind of humans, engineers and scientists, but they had a language that again could be mapped to different computers, and you could get portability and all kinds of good things. They didn't mean to. They just meant to give a language that was good for scientists and engineers. But once scientists and engineers have got it, everybody wanted one too. So you got 200 more languages that specialized for different things, COBOL for business people and such. And now you had a filthy mess. 200 languages and they couldn't talk together. You want to gather some data, you put it on records. COBOL is really good at that. Then you want to run some statistical analysis on it. Fortran is really good at that. Fortran doesn't speak to COBOL. And there's many particular solutions to that kind of problems, but the general solution came with Christian Nygaard and Simula, object-oriented programming. Basically, instead of giving people an abstraction that's suitable for a particular kind of user, you have a generalization so that you can build your own types, your own class hierarchies if you have related types. And that's a brilliant idea. And so when I had a problem at Bell Labs, I said, why can't I have both? I want to use every ounce of the hardware, but I want to abstract away from it when I don't have to be bothered with it. And that's the true root of C++. And the first feature coming into it was classes with constructors and destructors and things like that. And a lot of things come from there. So there are the two intellectual roots of C++, which I suggest it's a good idea to stick to. So C++ in 2 lines, not 1,300 or 1,400 pages, but if you really want to get to the basic of it, that's where it is. Direct map to hardware, came originally from C. And for future, we need facilities for dealing with the hardware that's now coming out. We can't just program against 1990s computers, which is what we do when we misuse a current computer. And we need zero overhead abstraction. We need to abstract, but I don't want to pay for it. Simula showed us the value of abstraction. Where I came in was I wanted it at no cost. And that's where you get you get this from classes, you get it in inheritance, you get it generic programming with templates and such. And for the future, I want type and resource safety with concepts, modules, and better concurrency support. So that's C++ in 2 lines. And let's get a little bit concrete. You have to choose your level of abstraction when you deal with C++. Here's a very trivial, simple example. I want to read some strings into a vector. I can do it on the top, I can do it at the bottom. There wasn't room for the overflow check, so sorry. I'm having 2 slides on two examples on 1 slide. To give an example, I would prefer the top, and I would prefer the top to run at least as fast as the bottom. For many, many application areas, that is possible. So you can start with what you can do, and then you can improve it. And the aim should be the higher level, the clearer, the type-safe thing, where you don't have to worry too much about the overflow and things like that. The distinction is fluid. You have a choice. But I would like to push people toward the more elegant solutions. You also have to ask what matters. A lot of the things we talk about don't actually matter in the big picture. For software development, first of all, that's what matters, not who can have the cutest little example in an article. What actually matters for actually building things? Stability, important. There's a lot of 20-year-old code out there. And evolution, There's a lot of new problems coming on. We must do that. We have tool change, we have teaching and learning. There's lots of people. I get mail every week from people asking questions that relates only to Turbo C++ 4.0. This is sad. We have to improve teaching and learning. I always mention that, and it's really hard. There's so much inertia out there. There has to be a technical community. None of us write a program in isolation. We depend on the advice of others, the support of others, the tools from others, the ideas from others. We have to build that community. This conference is part of that. I want concise expression of ideas. I actually want to be able to read your code, and vice versa. If it's a mess of bits and bytes, often I can't. Coherent language, complete language, compact data structures, lots of libraries. These are the things that are important, as opposed to language technical little details that also has to be right, but they have to support this. And one of the important things to note is that there at the bottom. A language must be good enough for everything you're doing in your project. If it totally fails at one thing, it totally fails. So being the world's best at one or two things is not sufficient. You have to be really good at some things, preferably lots of things, but you mustn't totally fail anywhere. So that's good. And it's really hard to do because you don't know what's important to people. There's far too many people to know what they want and what they need. I mean, we've got 4.5 million C++ programmers. I mean, even if I was a mind reader, I couldn't read that many minds. So this is difficult, but don't get obsessed with details. There are times to be obsessed with details when you finish one little corner of a project, but sometimes you have to look at the big picture. So a language needs good fundamental features. That's important. And a good language is not just a set of good features. You have to have them fit together, and the overall framework has to be comprehensible and effective. You have to be able to use language features in combination. You have to be able to have real compilers generate good code from them and things like that. And 90% of the work of getting something new into a language is integration. I mean, people always come, they send this email and say, put this into C++. It's cool. Even if it is cool, even if I agree, well, the first 10% is to write the proposal, and the next 90% is to figure out where it was wrong and why it didn't fit in and get everything to work together. But the discussions tend to be an individual feature, especially until they can be tried out, until they can be seen in context of the standard or of a tutorial. We need to spend more time looking at individual problems, individual features in the context in which they are used. I mean, these kind of design issues. So let's look. I tried to articulate rules of thumb in, I've done that several times, like in the design evolution of C++. But here's a list I found from 2003. Stability and compatibility, yep. You want new features, but you don't want me to break your code. Libraries are good because we can deploy them today rather than waiting till all your compilers have been updated. There are many projects for which you can't get away from, say, GCC 4.3. And it doesn't matter what the standards committee does to improve the language if you still have to use a 10-year-old compiler. So we really have to help people getting off those compilers. And, but we have to make sure what libraries is one of the things that helps us. Generality, the point is we have hardware, we have abstraction. We go for generalities rather than language features that solves particular problems. And support both experts and novices. I've been going on like this for a long time. I gave a keynote here called Make Simple Things Simple. And experts tend to want really important, clever, highly performing, sometimes specialized things. Think about the poor novices. Think about yourself, who's a novice doing the other 90% of what you're doing when you can't do your specialty. And great libraries help there. Increased type safety, improved performance, and ability to work directly with hardware, fit into the real world. I mean, academic papers are nice, but you really want to help people building real systems. And again there, change the way people think. That is where the order of magnitude improvements are lurking. Okay, and this has been going on forever. Let's see. Simple things, simple. In the dark ages, we wrote a loop like that. Declare a variable, then give a start condition, a maximum, and an increment. That's fine, except sometimes you misuse the loop variable, so found a way. Just stick the loop variable into the loop thing, so we can see where it is, if you don't need the value afterwards, of course. And in 2011 made another improvement. Why actually mention the loop variable? I just want to go through a container, an array, or something. For when I want to do that, which is 90% of the time, we can just write the range for loop. So basically the assumption here is the 2011 thing does 90% of the cases. The 83 thing does 90% of the rest of the cases, and then you are back to being able to do absolutely everything, including all the bugs you don't like. So hence the last line there, which shows that if you can do anything, you probably will. Those are real bugs found in real programs. So when we go on about the language and think about what to do, how to improve it, there's a lot of design decisions that should be made. There are only a few of the design decisions that are really key. I tried to list them. There's still a lot of them there, but you start from the beginning and you add things on it based on experience and all of that. Let's see. The key things here is what kind of programming is being enabled by the language features. A language feature in isolation is boring. Could be seen as intellectually interesting, but I think it's fundamentally boring and it's fundamentally useless. If you only had a loop, you couldn't write real software. So we started in the beginning. The roots of C++ is in the building of user-defined data types. Constructors and destructors, the way structures and classes are the same. I decided on C compatibility for good and bad. We got macros there and includes. Trying to get rid of them ever since, but it was a decent start. It allowed me to support a user after 6 months. It's not a 10-year project. The language is a multi-10-year project, but getting useful results not. About 84, 85, we could support object-oriented programming as well as anybody else. And sort of modern C++ is about 88, 89 when the start of standardization with exceptions and templates. We can do RAII, we can do a bit of generic programming. And we had to figure out what generic programming really was. The STL helped. Metaprogramming comes along later. It's still too complicated, but we'll deal with that. And now, where are we doing? I'm hoping to see the type and resource safety soon. That is a new collection of language features that in combination deliver this kind of type and resource safety without loss of performance. I have not forgotten this hardware. And we are getting better support for functional programming. We'll see. I put it out at beyond 2020 or thereabouts. Notice that the main decisions come sort of in clusters. There's one in the early 80s, then things are happening up till 88, and then it takes some time to learn. Things gelled in 11 again around generic programming and such, and we're not there yet for most other things. So basically, one of the things I look at here, see, major changes comes in burst. You need a lot of you need significant features, and then you need polishing, integration, and then you can go from an idea to actually a deployed new way of writing code, a better way of writing code. And they come in bursts. It takes time to get there, and then it happens. And most changes aren't major. I mean, minor changes can support status quo, but you're still writing code the same old way. Minor changes can be useful, they can be very comforting, and some minor changes are of course necessary to support the major ones. But if you want to get to the next level, if you want to get to the next stage, if you want to make significant improvements, not 10%, not 40%, we can argue about 2 times and 3 times, but usually I think let's get some factors in there. 10 is a very nice factor, and I'll take 2. But if we want to do that, then we need major changes. And we need major changes because we're not in the Middle Ages. Things are changing all the time. Our problems change, we change, and so the language has to keep up. And major change is unsettling. That is well known. If somebody comes with a radical new feature, a radical new way of doing things, even if it can coexist with existing code, which it always can, C++, it is still unsettling. You have to learn new things. You just thought you knew everything. You may very well have known everything about the world as it was 5 years ago. It's not good enough. So we need to make changes. And we have to make decisions. There are a close to infinite number of directions you could go in. We can't go in all of them. We can't focus the language if we don't make decisions about going roughly that way as opposed to go roughly that way. And that is hard to do. So here's another view of this. I think early C++ finished about 88, 89, and there was a commercial release. And it took people maybe a decade more to actually figure out how to use this, to deploy this, to support this, to get libraries, compilers, analysis tools, the works. And after that, there was a slowing. There was a feature drought. We didn't get anything significantly new during this period of time. A lot of work, it stabilized. STL sort of saved us from really fossilizing. There was a lot of work to be done, and the alternatives to C++ was improving. I think we actually didn't do enough. C++ doesn't have a sugar daddy that can give us marketing and research dollars and development dollars. The standards committee was working hard on stabilizing things, so we were losing traction, and C++ is dead was very popular in the press, but then it always is, but it worked. And so I was thinking now, why didn't this send us into a death spiral? Because you can see I'm complaining, but the numbers are going up. I mean, they're still going up by hundreds of thousands in this area, and I'm complaining? Most people wouldn't complain if they only got another 100,000 users. Anyway, I think there was a drop later, but the thing that saved us was the CPUs stopped getting faster. You couldn't just ignore performance. You couldn't really ignore the zero overhead and the zero overhead abstraction anymore. You couldn't ignore the weirdness of the hardware anymore. And that is what I think helped C++. And then 11 came along, C++ 11, which supported features that have been developed and integrated and understood in the previous decade, and we're on an upturn again. And so I would really love to know what's happening to that curve. Are we going into another stabling out, leveling out, and downturn, or are we going to carry on for a while? I hope we're going to carry on for a while, but we have to get some things right. We are not going to maintain that curve by doing nothing. We are not going to maintain that curve by doing only tiny things. Okay, so an apology. We need great libraries. The standard is now more than 50% standard library. I can't talk about. Just like I can't talk about the industry in general because I don't have time, I can't talk about libraries. So apologies, go and see the talks about libraries at this conference, right? Okay, great libraries, so I'll say. So go back. Let's see, what can we do that is significant? And how can we avoid it becoming an intellectual exercise that never ends? That's back to the philosophers. Oops. So when you ask people what's a good extension, if you talk to people about extensions, what is useful, what is needed, what should be done, you get two very distinct answers. Here is the semi-caricatured developer's point of view. I really want something that helps me with my next project or my current project. I want a very specific problem solved because this is what's bothering me, this is what I'm spending all my time on. And really, I don't have time to go and read a book. I don't have time to read an article. I'm busy, busy, busy. Don't tell me anything I don't already understand. Just give me a better tool for doing it. And make it isolated so I don't have to rethink and recheck everything else. And don't break anything. Mustn't break anything. This is bad. And it should be in my compiler tomorrow. Thank you. I hear that often. And there's a picture of sort of a typical developer that's so busy looking at his current problem that he can't see the forest for the trees. This kind of input, this kind of experience, it's genuine experience. We've all been there, right? It's real, but it's misleading. Very often, people who go on about that lacks experience with long-term planning, or at least they've never seen the results of their planning. Aims can very often be set by others. That is, people are trying to finish this project that they had no say in, and they're spending 90% of things that probably nobody should spend time on, because some bozo didn't define the problem right. And you can have very short-term evaluation of consequences. That is, did the product ship on time or not? That's the proof of the pudding. For the view of a programming language and the development of programming styles, that is not a good criteria. Deliver on time, focus on the details, and don't screw up. Very important not to screw up. If you have a mortgage, don't screw up. Okay, but this is not the way we can design a language. There's the other extreme here. There's the typical designer spouting theoretical something or other. And basically, we need to help the user community over the next decade or such. And we have to address fundamental problems because that's where the fundamental improvements are. Change the way people think. I keep going on about that because it's important. Make the language more regular and therefore easier to use. Be theoretical sound. Theory is a lousy guide for what to do, but it's an excellent guide for how to do it. Once you've decided what you do, you have to be sound. And improve the reputation of the language. It's not enough that you could do things in a corner and nobody hears about it. Again, the theory and the literature can be very misleading. Just as misleading as the environment of the developer can be the environment of the designer. There's a lot of focus on novelty. If it isn't new, it can't be published. Who said that what can help us most has to be new? Most things were invented a long time ago. And we have to revise them, we have to engineer them to be useful. That's not often seen there. There's a real focus on being clever. You have to solve complicated problems. If you have a simple problem and you solve it, you don't get much credit, even if that simple problem is something that is the right royal pain in the neck to a few million people. And focus on advanced features, again, have to be clever. And quite often, if you look at the literature and you look at theory, I think it basically disdains everyday programmers. I mean, that people, we should do things this complete new way and just rewrite all your own code. And if the programmers are more than 32, they should be fired anyway because they don't understand anything. There's some kind of attitude there. Obviously, my conclusion is that we need both. We need to somehow combine the everyday developer experience with a design perspective that spans years and decades. And that's a lot of ants there, and you have to keep a lot of them in your heads at the same time. You have to balance, and this is seriously hard. The C++ community is enormous. It's so easy to be parochial. All of my friends do things this way, it must be good. All of my friends have this problem. It must be solved. All of my friends like this solution. We must choose it. Okay, how many friends have we got? 1,000? That's not 1%. It's about 1% of a percent. How many of us talk to 1,000 people regularly about serious things? It's really easy to be parochial, to see only what's going on just around you, or read the same magazine and get the same kind of stuff that some journalists thought was important. And we have to work on within the current C++ implementation and infrastructure, because we have to consider transition. And then, of course, again, we have to get it right, but then we have to be able to teach it right, so that people don't write 1984 style C++. Some of us have been there and done that. Some of us do not want to go back. We can do better now. Okay, more examples. I distinguish between major features and minor features. Major features are the ones that has potential for major improvements, and minor ones are comforting and can help a little bit. So basically, major is change the way we think about code. And you can have combinations that are really, really powerful and interesting. Yeah, I'm not saying you don't need any minor features, that would be ridiculous, but the driver should be the major features. So we have literal separators, digit separators in C++ 11. It's very nice. Okay. We also got auto. It's sort of borderline major minor. If you just use it to initialize a variable, and so you don't have to say double for that x, it's minor. If you use it to eliminate over-typing in generic code, it's getting close to significant about how you write code. And if you get concepts, you can actually make a major, major difference. People always underestimate concepts when they haven't tried them. And so there's this range of things. And one of the problems is that people will spend as much time on the literal separators as they will spend on thinking about concepts. As a matter of fact, they might think more about it because it's so much easier to think about how do you separate digits. Do you use an underscore or a dash? Should you use white space? So easy, everybody can have an opinion. Everybody can have an opinion on concepts too, but it actually takes time to have an educated opinion. So it's harder to discuss that. There's isolated versus pervasive impact. We're getting in C++ 17 inline keyword for variables. And this is a very nice, from a language technical point of view, feature. No new keywords, new grammar impact, no type system impact, no impact on old code. And best of all, it makes it trivial for you to introduce global variables in headers. Some people think that's a good thing. I don't. The last thing I need is a new way for you to sneak global variables into my concurrent code. But you're going to get it, and I have read articles that it's really good for you, so be my guest. Another feature that I was trying to get into C++, connects to generic programming and such, is I want to be able to call a function with a functional syntax or the member syntax. No impact on old code, and it eliminates the need for duplicate functions. Have you seen begin, end, or x.begin? Which one do you want to use? Why? Forwarding functions, there's a lot of forwarding functions and binders and such can be eliminated. Here's a forwarding function that I found and shrunk to a something that fitted on a slide. Basically, it calls foobar with the functional syntax. I should have used the other syntax in there, foo.bar. But basically, it can simplify the way you write code and the way you design libraries. This one went down in flames because it was too different, new, and therefore dangerous. You might get the wrong function, as if you couldn't get the wrong function today. Okay, let's see. One thing we have to remember is every extension does some harm. There's people that think that you can just get new things and that everything will be happy. No. You need implementation, tool, and learning. That takes time, effort, resources. It outdates learning material, and compilers and libraries tend to last longer than you'd think, like decades. Remember that Turbo C++ compiler I get questions about? That was 20 years ago. It's still bothering people today. And you can have a poor benefit cost ratio. That is, you can have a feature that helps me. It helps all of my friends. I can demonstrate it helps 100,000 people. How can you say it's not good? Let's see, 100,000 divided by 4.5 million. This could be that you are imposing a burden on the other 90% or more of the users that doesn't give them any benefit. And it may delay new features that are necessary for other people. It can distract from good implementation of new features. It can distract from the optimization of existing code, of porting to other machines, things like that. There's no free lunch here. And you may actually get features that makes it harder to move in a direction you would like to move to in the future. Like I want better concurrency, and if you want global variables, they get in the way of each other. Okay, now, we also have to remember that if we want absolutely 100% portability or compatibility back to the dark ages, we have some problems. Sometimes we have to break it. If so, break it loudly. There's a static assert, good stuff. If you feed that into an old compiler, it'll tell you it's not compiling that dialect of C++. Well, use an up-to-date compiler, fix the old compiler, or use a compatibility switch. There will always be a backward compatibility switch in the compiler. You don't like them, you shouldn't like them, but it's a solution. There's a little change there in the meaning of auto coming up in C++ 17, unless the committee changes its mind. This will break some very rare code that think that y is an initializer list instead of an integer. Most of that code, it could be a silent change, but how will you use that y without getting an error if you think it's an initializer list and the compiler thinks it's an integer? Yeah, there's code, you can construct it. I don't think there's very much of it. So basically, we have to break code sometimes to get modern code looking better, working better. Try to break it loudly, and if not, hope it breaks often. Okay, I think we need a direction. That's a major point here. We can't just go in all directions. We need principles, consistency, coherence, completeness, interoperability, zero overhead. Good. It's hard to do, harder than it sounds, and we need a process to help us follow those principles. It's really hard with lots of individual decisions. I mean, a standards committee for a new standard has to make thousands of individual decisions, and they can't sit around looking at philosophy all the time. But it would be nice if there was some guidance. And you need concrete examples. People are amazingly good at misunderstanding text, especially on general principles and such. So we need something. So creating and maintaining a direction is quite difficult. Most people want a smaller language with more features. This is hard. It is actually possible to get the effect through generalization, so that there's fewer rules you have to know because things work more in general, but it's hard. People want stability, 100% compatibility, and with significant improvements. Except for the people that just want to break the whole thing and go and do a revolution. For those, go and do your revolution elsewhere. This is an old language. It's going to be a much older language in the next 40 years, and it's going to be quite good, and we can't break the code. It's our code. It was written by our colleagues and our friends, and it's still going to be written by our colleagues and friends for the next decade or two. Whoa, this is a good trick. So we want stability. And some directions are mutually incompatible. We can't both go that way and keep things small. We have to make sure these things combine somehow. And the Standards Committee has no money, no resources beyond the volunteers that do all the work and have to pay for the privilege of doing all the work. And the more features we add, the harder it is to integrate, so the amount of work increases. And then, of course, there are people who disagree on fundamental philosophies. I mean, do you want implicit things in the language? Do you want a very explicit syntax for everything? Do you want it simple, so that you may only handle 90% of the cases, like the range for loop? Or do you want everything to be fully comprehensive, like the original C for loop? Then there's aesthetics. People disagree about what looks good. And then there's always a discussion about should we do things in the library or in the language. And I think C++ is a victim of its own success. Everybody wants to help. The Standards Committee is bigger than it ever was, more active than it ever was. And I think the individual technical expertise of people in the committee is higher than it ever was. But it's really hard to be coherent. A lot of people come with totally different background and doesn't appreciate that other people have different backgrounds, different concerns. And a lot of people have not internalized the C++ process, where the language is going and why. And then, of course, there's people who've been there for a long time, spend all the time trying to rehash what we should have done 10 years ago. Well, that was 10 years ago. We can't do much about it today. And so we have a long series of separate decisions, quite often done by people who hasn't been in the room with the other decisions, and it's hard to be coherent. And sometimes people come in the last minute and says, we can't do this, this is horrible. And he says, we've discussed it for 3 years. Well, I wasn't there. Why didn't you tell me? Well, we did tell you, but it drowned in the details, the mass of information. There's more than 100 papers coming for every standards meeting. Not everybody can read all of those and understand it and contribute. This is hard. And by now it's not really designed by a committee, it's designed by committees. There are subcommittees, there's people that never actually spend time discussing the features together. This is very difficult. Anyway, we should thank the committee. It's done a good job over the years. There is a very tired committee down at the bottom, just after voting out C++ 14. I think they might be voting up the top slide there. And the final thing is where people do a lot of the real work, which is in the working groups. And notice all the computers there. Everybody is sitting there doing their various things and communicating with their friends in other countries and such. If you go into a room in the Standards Committee, you see 15 people sitting around the table. There's probably 30 people in the room because they communicate. okay, one of the examples here. I mean, why should complex be in the library and not in the language? Why should a range 4 be mostly in the language and not in the library? There's a whole set of decisions there that actually are not that hard to do. Not that easy to do. This is a discussion that you can have for every single feature. C++ is powerful enough that most things can be done in a library, and especially if you put in a few intrinsics. When you do that, you can sometimes deploy it early, which is good, and you increase the compile time. This can be very bad. So we need to deal with that. Here's a simplification thing showing how things work over the years. So in 98 or thereabouts, we started using things like pair, and we have to say a pair of what and initialize it. With 11, we could say make pair, and it'll deduce the right types, and we can use auto so that we don't have to sit and repeat ourselves so much. And in 17, we'll be able to have the template arguments deduced from the initializer. Cool stuff. So progress happens at the smaller level. This is the kind of simplification that will help people. It'll also confuse people who read old code and can't understand what the new code is doing, or get used to the new code and get confused about what the old code is doing. You can't actually have change without some cost. A direction. I think we should talk more about the future. It would be nice if people agreed on a list of things we would like to see in 5 to 10 years. And it would be nice if people had an agreement about roughly what we would like for the next standard in the 3-year horizon. We are not having those discussions. We are not having those lists. It's bad. Most people don't articulate their aims. I do, but often people fall asleep or don't read them. And we should be explicit about this. We should be articulate about it. We can't spend all our time discussing the details, and that's what I feel what we do. And furthermore, the last one is very controversial. I want to integrate things early. I want to see it in the standard document together with the other things so that we know that things are work together or not. A lot of people want to delay things until they're perfect. Remember Voltaire? Well, best is the enemy of the good. So some philosophy, we will make errors in language design, like in program design and such. So let's get them made. I'm for early integration. I'm for moving ahead. We know we're going to make mistakes anyway, so let's get used to it. And we should maximize our successes. We shouldn't just minimize failures. Of course we don't want failures, but we are going to make mistakes anyway, so let's make them and fix them. Any change carries risk, including not doing anything. And we have to be confident. I think we are getting too nervous that we might make mistakes, forgetting, 1, we do make mistakes, and 2, in the past, most of the time, we've been able to fix it before it was shipped or before it was significantly impacting the community. Look, if you're a library writer or compiler writer, it hurts having to back up something. It hurts when something breaks. But that's life. And if we have to move on, we have to take some chances. And one thing people do a lot is to confuse familiarity with simplicity. If it looks the way I'm used to, it's simple. It is many people's definition. No, it's not. It's familiar. It may be simple. You have to go for simplicity, especially in major things. So a problem we have is that we can't actually explain what C++ is. And if we can't characterize what C++ is, how can we explain what it should become? I mean, we have to have some kind of agreement what it is. I have my suggestions. It's a language for defining and using lightweight abstractions. It's aimed primarily at software infrastructure and resource-constrained applications. You have long papers explaining what that means. Who are the language for? I mean, it is not for people who want to do a quick web page. I used the phrase serious programmers in the first edition of the C++ programming language. It's actually the first sentence of the first edition. I used serious. I edited out professional slightly early because I realized some of the amateurs were better. And so, but people that take the act of generating good code or writing good code, maintaining code, that's serious. And that's what C++ is for. It's less for casual programmers, unfortunately. There's a lot of those. They do really good C++ at times. But only if the serious ones get their tools and their libraries and such in place. And what would make the language better? We have to specify what it means to be better. You've seen some suggestions in this talk and in writings, but we have to be specific to make forward. And so we can't please everybody, but maintain the direct map to hardware, the zero overhead abstraction. Language is primarily industrial. We'll never get it pretty enough for every professor to like it for teaching freshmen. I've taught freshmen, so thousands of them. It can be done. It's not even that hard, but you have to do it right. But primarily, C++ is there because we can build good systems for people. And then it rewards good programmers. I mean, if you are a good programmer, you shouldn't be stopped from doing good stuff. We should make it simpler for a good programmer to do good stuff in areas we don't know. In application areas we don't know. In application domains we have never heard of. It's good. It would be really nice if we had a buzzword for saying this. I don't, I'm sorry. And every time I've tried to find out good words, I learned why I shouldn't be in marketing. Now let's try and look ahead a little bit. My high-level aims, they were first for C++ 17 and beyond. Now they're just for C++. Let's not put a specific time scale on this. Improve support for large-scale dependable software. Support high-level concurrency. Everything is getting concurrent, so let's support it well. Simplify the core language use. You can't simplify the core language, that will break your code. We can simplify its use. Ranges, auto and things like that can simplify, range 4 and auto and things like that can simplify your code. And then we have to address the major sources of errors. That can be through tools, it can be through coding guidelines, it can be through language features and libraries. Preserve the fundamental strength. C++ has to remain C++. If you want something that's fundamentally different from C++, go get it. C++ is not for everything and for everybody. We know that. But don't abandon the past. Don't get stuck in the past. And avoid small feature creep because there's so much stuff there. So there was my top 10 list for 17 as presented I think in February last year, and I was very optimistic. I thought we were going to get concepts. I thought modules were so far advanced that it would be a stretch goal, but we might be able to get it. There was a range library. It's marginal, might get it. Uniform syntax, coroutines, the shipping, networking, it's been shipping, contracts, yeah, stretch goal. SIMD vector and parallel algorithms, that is going well. Library vocabulary type, optional, variant, string span, yeah, it's going. And a magic stack array type because stacks are really useful things and it would be nice to have proper arrays on them. And well, I learned the hard way, it's hard to make predictions, especially about the future. We only got the two things that are pointed to there, and only partially. And all the rest is postponed. That's, I'm a bit sad about that. Here's what you actually get. And here's a list. And the problem is that all of that basically is in the minor category. A lot of minor improvements can add up to something significant. Most of these will help somebody in some way, so there's something for everybody here. I can't imagine any C++ programmer that will not have at least some relief from pain in C++ 17. Will not be able to write some piece of their code better in C++ 17. So what I'm concerned about is that we are not moving fast enough and we're focusing on too small things. And let's see, library features. Well, it's not a library talk, so I'm not going to go into that. We're finally getting the file systems and some parallelism kind of stuff. Okay, so what do I think now, after the last year or so? For C++ 20, and hopefully available before 20, I would like everything C++ 17, and I would like my C++ 17 list, because it still reflects the way I think the language ought to be going. And operator dot, I want smart references, finally. They were about the first extension proposed at the second meeting of the C++ Standards Committee back in the dark ages. I think we finally know how to do it. Default comparisons, it was rejected by the standards group. I think they got it wrong. And beyond that, there are things we need to look into. We could use a package manager. We could use a standardized representation of C++ source code that we could use for tool building. IPR is something that Gabby Desrays and I did a few years ago. It's a general representation of a language for a superset of C++, fully typed, minimal in all possible ways. It would be lovely if we could get something like that. There's work on static reflection. I would like to see that come in. I've been experimenting with functional programming style pattern matching, so we could finally get safe use of unions and such. Part of this idea of making things simpler and making them safer. And high-level support, concurrency support, I'm not going to be specific there, but I don't want to fiddle with mutexes and worrying about data races and such. We can do better. And then I fear that we're diluting the effort. I mean, we have 100, 200 people in the committee. We have 1,000 people in the community that contributes. If we don't watch out, we'll get nothing because we are all over the place. And if you look at this list, I did not expect I would get everything in 17. But I expected I would get something. And this is not much. If this has been a project with a project management and such, we would have shipped a couple of the major things. And you would have been busy learning about it and upgrading your code. As it is now, it's harder. It's lack of focus that does it. So what do we do now? We'd have to get ready. Upgrade to C++ 14 if you haven't already. Lots of places have upgraded to 11. It's easier to upgrade from 11 to 14. This is good. If you're still stuck in 98, either mindset or compilers, upgrade. It's the best way of getting ready for the future, is actually at least get to the present. Furthermore, your code will run faster. If you compile with a modern compiler, your code will run faster because it will target modern architectures instead of using the backwards compatibility features of your CPUs. Upgrading from an old compiler is a good way of finding bugs and to run faster. And try out the TSs. I mean, you can get concepts. Ranges are there to download and use. The networking library has been in production use in many places for the last 5 years. It's great. Coroutines are shipping, mostly by Microsoft, but I hear there's a Clang implementation also. Try them. You can do some really cool pipelining very, very fast. And you can do it today. Modules, they're coming. There's talks about them at this conference. This is good. And then I'm still working on the core guidelines that we announced last year. They've improved. I'll get to that. Improve them, improve tool support. So let's look at concepts. It's a technical specification. It's shipping GCC 6.1. The most important thing about concepts is that you can improve your specification of your generic code. And you can get simpler generic code, like you can do overloading based on concepts rather than writing enable if messes. And you can get better error messages, and by the way, it compiles faster than the alternatives. And so basically I want to see code that says I want to sort anything that's sortable. And so if I sort a vector, it's sortable. What does sortable mean? The definition is over there somewhere. It is a sequence that is random access with elements you can compare with less than. Okay, translate that into C++, it's 4 lines, and you're done. By the way, you cannot sort the list. Why not? The standard says so. It says that the list is not a random access sequence. And so the error messages will tell you that it's not sortable, and it'll tell you that it is not random accessible, and it's not random accessible because it doesn't have substrate plus. There's been some discussions about the quality of the error messages. Some people want more, some people want less. I've forgotten what they're shipping in 6.1. It used to be that there was a switch so that you can say how much you wanted. I always wanted less. Andrew Sutton, who wrote that compiler, always wanted more. It seems that people these days out in the community usually want more. They'll get over that. Once you learn to use the concepts and know the concepts, you'll want less. I want that switch back. Concept design can be used in the comments. You can actually design your code around concepts. You could actually design your code and test it out on the Microsoft compiler, comment it out, no, sorry, not the Microsoft, the GNU compiler, and then port it to whichever compiler you're using. Just put a comments in place, and when the other compilers catch up, take the comments away. And you can use the concepts from the ranges TS. There's a good set. You don't have to start from scratch. Then we are going to get modules, almost certainly. And this is the way we write code today. We include some files, and then we use them. And there's some data I got from Gabby Does Raise. There is 176 bytes of text that you wrote to get this little example. It becomes 400 plus kilobyte GCC, just over a megabyte with Clang or Visual C++. Now, our compilers are very, very clever to actually ever get finished with all of that text. And that was only one file. You're going to include that stuff 100 times, and it's going to be bigger. We are simply going to radically decrease the amount of data processed by the compiler. This ought to give significant improvements in compile time. I don't have any numbers, unfortunately. To use it, you need better code hygiene. If you have undisciplined macro usage, you're not going to get that much advantage, because if you have old code and you demand your compiler does all the old way of doing things, you're going to get the old performance. So some cleanup will be necessary, but once you've worked this in, get code hygiene, get fast compilation, you just import the libraries, and then you use them. To write a module, it's not rocket science. You can introduce it gradually, have some stuff that uses the includes and the macros, have some stuff that encapsulate it, have some stuff that doesn't use it anymore. And basically it's based on 2 keywords, one for getting things in and one for saying you want to get it out. There's lots of details, of course. There's at least 3 talks at this conference that'll tell you about the details. So I'm not going to do it here. I'm just going to say we have the hope for simpler code that compiles faster. And if you compile it with things like concepts, it gets even faster, you get better error messages and cleaner code. We're working on a contract. It's it's a proposal now. We're working about it. It's sort of assert on steroids. And it's selectively enabled at runtime. So you can say preconditions, expect that that the queue is not full. Post conditions, it makes sure that once you have pushed something onto the queue, it's no longer empty, and you can have assertions in your code. So that simply standardizes what a lot of people are doing with special code or macros and such. And there will be 3 levels of contracts. You can argue whether it should be 2, 3, or 4. Currently it is 3. Basically audit, which is big expensive checks. Default, which is relatively cheap checks relatively to the algorithm that's being done. And axiom, which is basically not checked at compile time. You can write things like that. And we're going to get something called structured bindings. It's voted into C++ 17. It's coming in compilers right now. We'll probably be told this week whether it is in shipping in Clang. I think it either is or is close. Basically, you can give local names to struct members. So when you call something like a map insert that returns a pair, you can break out the pair. The one is an iterator and the other one is a success indicator. And so you can write code like that. One of the things it does is to work nicely with the range for loop things. So you can go through the map and for each element break out the key and the value and do things with it. Very nice stuff. And then the kicker here is that we designed things to work in combination. If we didn't do that, every feature would bloat by itself, and there would be endless overlap in the language. There's already enough overlap between features in the language, but these things can work together. So I want to write that code. I import IOStream namespace, I have a map printer, I write some code, it has concepts in it, it has structured bindings in it. I can't do it. Modules are shipping by Microsoft, concepts are shipping by GCC, and structured bindings are shipping in Clang. I will be really happy when I can get all 3 in all 3 compilers, because I happen to work on a place that uses all 3 compilers. I'm an optimist. People can tell me, will I get it next year? I hope so. Okay, again, thanks. We couldn't do it without a lot of people. Oh, I shouldn't have said that. I myself, I'm up there. I shouldn't. Okay, I'm not that guy there. I'm not thanking, but the others I'm thanking. Okay, they've all done hard work to get us to where we are today. And again, if I put everybody in, the font would be too small for you to see it. So I just picked a few that did something. Until now, the other thing we can do is we can work on guidelines for how to write modern C++, how to clean up old code. I gave the keynote last year on that. If you haven't seen it, you can. But basically, we want to guide people towards a better, more effective, more efficient, better style of code, develop the style, and we're aiming at type and resource safe C++, no leaks, no memory corruption, no garbage collector, no limit of expressibility, no performance degradation, and in strict ISO C++, tool enforced. I'd hope to be able to say I could do this at scale today. I can't, it's not at scale yet. But there's a lot there. There's a lot that wasn't there last year. So progress is being made. There's the links to the to the guidelines. There are the links to the support library we're using, and we can use all the help we can get. And the static analysis tool support that has started, you can actually get something out of a few of them. I just wanted more. So the status is we've got 423 rules, which is of course too many rules because people can't remember 423 rules, can't even count that high. On the other hand, the idea is that the tools will help you find where you made a mistake and dump you to the right place in the rules so that you can read what was the rule that you are not supposed to break, why is it a good rule, examples, and what can you do instead. And some of that is in place. There's beginning industrial use, usually an organization, subsets and supersets to fit their specific needs. That's good. That's expected. It said so in the introduction even last year. And there's some starting use in teaching commercially and in academia. So after a year, I guess I shouldn't be, I'm impatient and I wish there was more, but maybe I shouldn't be. The fact that 1 year later it's getting into academic curricula is pretty good. We wanted better tool support. I thought it would be better. Well, apologies, things happen. We're working on it, and if any of you are tool builders, I encourage you to think about it, look at the guidelines, contact the guidelines editors. You can find us on the GitHub, and I'm one of them, so not too hard to find. Herb Sutter is the other main name on the paper, and expect more. And again, thanks. We have, I don't know how many contributors. 12 squared, and lots of issues. I hear about translations into Russian, Portuguese, and Korean. I can't read those languages, so I don't know how up to date they are or how good they are, but somebody's trying. Our general approach to just about anything is sort of the cocktail of approaches. We use low-level stuff, like in the GSL, the Guideline Support Library. There's an owner annotation that means nothing, it's an alias, but it tells you it's an owner. So static analyzers and humans can understand that you're supposed to delete that thing when you're finished with it. At the higher level, where things are better, you have abstractions that represent ownership, vectors, unique pointers, mapped shared pointers, and stuff like that. And we have support for optional range checking. We go one level up, span, string span, not null. You can express things directly, and you can either have the code check it. These library functions will actually do checking, or you could have the equivalent done statically. And then we have rule support. There are some things, just don't do it, or just do it this way, and you don't get into trouble. That helps. And we work. The idea is that the applications are built on the abstractions, and then you can verify them, as opposed to fiddle around with low-level stuff all the time. But sometimes you need the low-level stuff. Herb will talk a bit about that in the last keynote. And there's an outline of the guidelines. There's a lot of them. There's supporting sections. A lot of them are horribly incomplete, but not all of them. Some of them actually have teeth, and some of them actually have checking that supports them. Here's an example. Do not pass an array as a single pointer. This is one of the example of one of the rules where we have looked into seeing where the bugs are. And people passing a pointer, or a pair of pointers, and an integer that's supposed to tell how many elements there are, this is a bug source. It is a major bug source. Furthermore, it's a source of buffer overruns and other kinds of stuff. And so the rule is there. It's easily checkable. And there's an alternative. You can't just say people don't do that. I mean, what do you think it is, kindergarten? You have to give an alternative that is valid, applicable, and equally fast. And span in the GSL is an example of that. There's an example of how to get burned. Somebody thought it was a bright idea to have an array of elements of a derived class and then pass that to a function that took a base class. There's a double implicit conversion going on there. First, it converts the array to a pointer. Then it converts the pointer to derived to the pointer to base. And boom, if you subscript that stuff. Again, don't do it. The tool will catch it for you. I mean, you could say, I would never do that. Well, I'll tell you, some people do that sometime. Bugs are very often done by people who hasn't been burnt yet. And it would be really nice to help them. And that's what we can do. So that's the sort of structure. There's some exceptions. If you pass zero-terminated strings, that's fine. And enforcement, I believe this actually is available in the implementation by Neil McIntosh in the Microsoft compiler. And here's the example I gave earlier. You can use concepts today. And the recommendation is use concepts for all of your classes today. And if you don't use a compiler that understands concepts, put comments in front of them. I had a comment just this week about this rule and says, oh, you didn't mean policy types of something. And I said, give me an example. And the answer came back and says, oh, I tried to write it down and I realized that I needed these concepts. People who hasn't tried this stuff underestimate it. And if you don't want to start from scratch, go to the ranges TS and find a good set of starting concepts. It'll teach you some good manners and it'll help you get started by specifying the code better. Always initialize an object. I mean, we should do that, but there's a lot of clever stuff where people say, oh, don't want to initialize it yet. And then they forget. Or they write a complicated, if something is something, initialize it this way, initialize it that way, or else initialize it that way. Okay, you get it wrong sometimes. It gets too clever. If you don't want a thing initialized yet, don't declare it yet. If you have a complicated initializer, there's ways of doing it. Like, have you ever initialized a variable with a lambda that did some conditional stuff on it? You can do better. A rule like that gives you suggestions for how to do better. Don't just say, don't do it. Say why you don't do it and what you can do instead. And there's a lot of related talks. This is sort of my reason for not giving a language feature talk, apart from feeling that sometimes you have to talk about bigger pictures. There's a lot of talk at this conference. I mean, you want to know more about modules? There's modules talk. You want to know more about guidelines? There's guideline talks. Coroutines, it's here. Parallel algorithms, which I mentioned, they're here. And this is undoubtedly not all the related talks. In some sense, every talk at this conference is related, but in a stronger sense, it's available there. And so here's some kind of summary. C++ is successful. We have to build on what made it successful to sustain the success and to sustain the many applications that we depend on every day. And we have to focus on significant changes. We mustn't just spend all of our time on details. First you decide where you go, first you decide what is major, and then you can agonize about the details, not the other way around. And we can't wait for the committee and the compiler writers to finish everything. We actually have to catch up with what's available now. We have to experiment experimentation shows how we can use new features. It may even show you how new features can be improved while they're still in the design and decision stage. And there's the TSs, but especially in the libraries, can be used. Some of them are in production use now. I don't recommend all of them for production use, but there's no need to wait. There's a lot of stuff that can be done by us this afternoon. This is not just future stuff. Yes, those philosophers on the first slide, but some of it is really concrete. And try the guidelines. If you tried it after last year, you found it was incomplete. You try it now, it's still incomplete, but it's better, significantly better than it was last year. And yep. Oh, by the way, that picture is not of stars. It's a program that pretends to generate stars. So, in case you wondered. And so I think I have plenty of time for questions now. Thank you. I don't know, do we have a system with microphones and such? Yes, please use a microphone if you're asking questions.
How much can modules help with template-heavy code?
How much can modules do with template-heavy code? Quite a lot, because you can break templates down into something like the IPR. I mentioned the internal program representation. So you basically build a typed abstract DAG, not an AST, but something more advanced like that. And then a lot of the template work has been done once. And so only the final instantiation will be done once per set of template arguments, as it was meant to be done. So go and ask the people that are doing modules, and especially people that do both modules and concepts, like Gabby does Rez. He's down there with a hat. He's the right person to ask to. But modules plus templates, especially modules plus templates with concepts, is a very, very potent mix, both for compile time and for correctness. I want those faster compiles, significantly faster compiles, to find more bugs. I mean, it's easy to compile faster. You just postpone everything to runtime. That's not what I want.
Thank you.
You seemed sort of frustrated with the pace of the 17 standard. We didn't get a lot of the features that you wanted, and you showed the graph of where it went real fast up and then flattened and went real fast up again, and you're worried that seemingly, it feels like you're worried about it flattening again, and you want to try to forestall that. But I wonder if you could give some historical context as to, like, did it, when we were in the flat portion back in 2005, 2008, did it feel flat? And what was the committee doing at that time? That was before a lot of our times.
Okay, this is a very complicated question to answer because it spans decades and, well, millions of people and language features and industrial connections and everything. But yes, I'm very impatient. And yes, if I'd been dictator of the world, you would have had more features today, and people in the committee that didn't think this was the right thing will tell you I'm wrong. And I'll tell them they're wrong, and that's how we discuss things. Hopefully we are not, hopefully we're still friends after that. At the time, year 2002 plus minus 3, it did feel as if things were not going as well as it should. The committee was under the false assumption that you couldn't discuss new language features for 5 years. We actually believed there was an ISO rule for that. There was some kind of ISO rule that says you couldn't vote them in and change the standard, but we were wrong. We were also very tired after the effort of delivering 98, and I think we screwed up. And then fortunately, the CPU stopped getting faster and a few other things, and we sort of recovered. Alex Stefanov did us a real good favor by the STL, which created a certain amount of excitement when we needed it badly. So he had done that before the standard, but of course after the standard is when you get it available. So yes, I think we could do better, and yes, I think we can do things faster. I don't think any total disasters have happened, and I'm just trying to give my contribution to what we can do and why we should do it. And next year and the year after, we will know more, and I have high hopes. So a lot of these things are shipping that I've been talking about.
So C++ has this rich history of features following this pipeline from third-party libraries into the standard library and even into the language itself. For instance, move semantics were in Boost before they were in the language. But the path to the language is much rockier because the APIs for extending compilers aren't really there, and thus you often have these really dirty tricks that people do inside of metaprogramming or inside of all kinds of other things. And it takes a lot longer to get things into the language because of that. And that's really because the APIs aren't there. Is this something that the standards committee should be concerned with, or is that something that's on your mind? Should those be standardized, and why or why not?
Right, let me just ask a counter question before I try to answer. You said APIs?
Well, standardized APIs. I mean, I can't write a compiler extension that'll work with Microsoft and will work with Clang and Boost.
I was just trying to make sure it's the right thing. That is a very hard question. Traditionally, platform vendors have insisted they can do things on their platform, and compiler vendors are very keen of not breaking their current user base's code. Furthermore, there's been a concern that if we standardized an API like the Itanium API and said everybody had to use it, we would limit experimentation and performance. So this has been close to the third rail in discussions in the standards committee, and there has been people who simply wouldn't discuss this. And I don't have high hopes for this. If we could get a group of people together to arrange greater interoperability, you would have to have, for starters, Clang, GNU, Microsoft, Intel, and a few others to sit down and agree. And I don't think it'll be the standards committee that can do that. For starters, they wouldn't want 100 people involved in the design of a standard API. Furthermore, different hardware has different things, so you probably could not standardize across architectures. And if you can't standardize across architectures, how can you standardize across architectures that are still changing? So it's a really sticky problem. And since I've failed to make progress in that area repeatedly, I'm not going to make any promises. Complain to your compiler vendor. Encourage them to do something. Maybe not perfect, maybe there could be a compatibility suite or a conversion mechanism in place or something, but don't rely on the standards committee to doing that.
Hi, would you like to comment a little bit on the list that you have for C++ 20 and beyond and the weirdness of hardware? Because I didn't quite make the connection between how we're going to support this weirder hardware, as you mentioned.
The main thing that was missing on that list was specific things about improved concurrency control. I think we need higher level concurrency models. We may need some work in cache awareness. I don't know. Somebody may look into that. And we may see some work in the standard library for, say, flat containers of various sorts for using caches better. I just didn't want to go into details there. And I think a lot of it is a library issue, which is the main reason I didn't go deeper into it. Libraries with intrinsics.
In your growth chart, I think there were maybe 2 hidden things that you didn't point out that were maybe there is growth of communication like web and being able to get access to a lot of information, and perhaps maybe some key individuals like who have helped project the language forward over the last couple of years. And I mean, notable people who are at this conference. What are the way to, do you think those are actual factors in the growth of the language? And if they are, how do you capture that and make it go forward?
I didn't quite understand, could you?
So the idea being if there was sort of a lull in the growth of the language, yeah, and then it sort of took up, was that due to, maybe there are things in the list that are, and that you didn't talk about that, you know, I can find information easier. I'm able to learn about how to use a language better than maybe in 2000. And did that help with the language? And also now we've got a lot of people helping.
It's a complicated issue. The exhaustion of the committee members were important. So was the draining of the community by organization like Sun that was taking the best compiler writers and putting them on Java. And so was the fact that we had never managed to create a center for the C++ community. We don't have a central website, we don't have a central library exchange and things like that. We're trying now. The C++ Foundation is part of an attempt to deal with this. And then finally there was libraries that was missing, notably a GUI library. There's no standard for it, which we couldn't get because there was at least 5 organizations that was members of the standards committee that was of the opinion that their GUI was the best. And we could not move without insulting more than half of the committee, and that's not the way you move. There was other things. We're finally getting a networking library, but why don't we have a web access library? It's 10 years late. And well, this happened. It was 10 years ago. The question we have to ask is, what can we do today? And we're moving too slowly for my taste. I would have liked the Azure library to be shipped with 17. As it is, it's production, quality, and used. So use it anyway.
Hi, actually you answered a part of my question by talking about concurrency and cache awareness. But my question was more like, you started by saying that C++ has to be true to its 2 core principles of one, staying closer to the hardware, and second is providing minimal abstractions on top of it. It's just my opinion that as we are going towards C++ 17 and 20, I think the focus has more been on providing those abstractions better, whereas the focus is less on being closer to the hardware, and almost to an extent that if there has been a perception that if people say that if you want if you're really focused towards speed, you see. So what's your opinion on that our focus is?
There's a lot of impressions out there, and very often they're wrong. I think there is a part of the community and part of the standards community that's very interested in performance. I mean, in my day job, I sometimes deal with both high volume data and ultra low latency data. I can count nanoseconds now. I didn't used to be able to. And it's certainly not forgotten. Whether we popularize and spread the word well enough is another matter. And also whether the ideas that come forward are general enough to work with everybody. There certainly work with, for instance, integrating FPGAs and CPUs and GPUs on the same on the same chip, and we're aware of that. There's at least one cross-industry group that are looking into issues like that we know about, but I suspect that we're still waiting for some proposals for how to do that. Some people are talking about it. I think it's more an impression, an image issue than it is real. But anything we can do to get more known that we're working in those fields is probably good. I think there are talks at this conference that relates to better use of hardware. I suggest you look into it on the schedule.
Could you maybe say a couple words about the role of Boost in the past, and then particularly what you envision as a role for organizations like that in the future as far as making contributing to this effort?
Boost have made an excellent and important contribution to modern C++ in general, and to the standard in particular. They've tried out a lot of ideas. I would say only a few of them has any chance of getting into the standard, which I think is fine, because the standard is what has to be shipped to everybody, everywhere, and it has to work together. Boost is doing a good job, but they shouldn't expect more than, say, a 10% success rate if entry into the standard is the measure of success. I don't think it should be. I think usage should be. The other thing is that sometimes I think Boost over-designs and becomes a bit expert-friendly. And if I would make some suggestions to Boost, nothing I haven't done already, repeatedly, and actually sometime once at BoostCon, focus a little bit more on simple use, focus a little bit more on packaging. I would like to have sort of a novice's package of Boost stuff for the essentials, and then the enthusiast package, and then the experts only package. And I would not have to want to know everything that an expert needs to know to be a novice user. Examples like that. But I think Boost is one organization. It is not the only organization. I wish there was more, and I wish there was more code there, and I wish people would use it more. Without it, we would be sunk.
Thank you. I might say I think you underestimate your abilities as a marketer.
I mean, sorry. I am over. I'm being interrupted here. Sorry about it. There is a session for quiz the committee tonight. So if you've got committee questions, you go to that. And otherwise, catch me or others in the corridors. That was a hard interrupt. Sorry. Thank you.